Okay, so looks we are live. So if this one, the resolution is too poor, there should be in principle now the YouTube channel, but it doesn't look like it's working. Let me see, settings. You should stop canceling. I'm not sure if, so there are two things to it, right? Me getting it running and then the internet connection being fast enough here so that the signal is actually, yeah, now it's streaming, very good. So you see this here? So you go to YouTube MOS453 ISCP, and then if you have trouble seeing here stuff, you can just see the live stream, right? There should be. Let me check. Can somebody check? Is it working? How's it called? MOS. What is the course number? 453? 53. That's all not what it is. Four, 5, 3. Does it work? Anybody can confirm? Introduction Scientific Computing with Python. Oh yeah, here, live stream. There I found myself. Good. Yeah, that is me. Very good. So you can see my screen on YouTube. You can see it here. If the resolution is too bad, too good. There's an audio signal here. Fantastic. Okay, and then so we are here now on the Anaconda Navigator. We have a lot of different programs to choose from. For this course, we normally use the Jupyter Notebook. Okay. So I click Jupyter Notebook, launch. Very good. Takes a little while. Yes, no, maybe. Is it starting? Maybe. Zongshan Dashue, de. Don't tell me it's not working now. Maybe here? Nope. Okay, no problem. Oh yeah, now it is opening. Okay. So if your Jupyter Notebook is opening, this is your first graphical user interface, GUI. And it presents you some form of file structure here. Okay, so I have a lot of files. So far, so good? Can you see? So far, so good? Yes, I can see Jupyter's open. Very good. So what I do next is I go to New and I make a folder, you see? Good. And so I get an unnamed folder. I rename the folder. I call this Introduction to Scientific Computing with Python 2024. So far, so good. And then I go into this folder by clicking on it. So I click and then I'm in a new empty folder. So far, so good. And then I click new Python 3. And this will open a new empty notebook. And the notebook in Jupyter allows us to play around with code already, right? Pretty easily. So I have some issues connecting to my Python kernel. That means my Jupyter notebook might or might not work. We'll see in a bit. So how are you doing? Have you opened Jupyter? Is it working for you? Okay. So what we can do now is to structure code examples, and a little bit of information to it, right, in forms of text. So what I do now today is a hash. Let's zoom in a little bit. That's a hash used in hashtags, just hash. And then I call this without whitespace Python as calculator. Okay. But then I change the cell type to markdown. Shift enter. Restart my kernel maybe. Now with white space, then you see suddenly, oh, the font changes. The font size is changing. And when you press Shift Enter, you see a title, a caption. So far, so good. Shall we do it again together? I see a lot of excitement. So far, so good. So you need to select. So here, right? So my box is now selected the blue one. Don't select the blue one. Select the one above. So take the cursor, put your cursor on the text, and click with the mouse. Then you select this box. Okay? And then you go to cell. Go to cell. Cell type. And choose Markdown. Okay? Markdown, yes. And then Shift, Enter. You need to push two buttons, Shift and Enter at the same time. Two buttons, Shift and Enter. Okay. Yes. Markdown. And in front, don't forget the hash in front. So I click again. Look carefully. Look carefully. I click on it, double click, and I see the hash in front. The hash will tell you, hey, this is a title. Okay? We can play around a little bit. We have two hashes. Adding numbers. Then I go again, cells, cell type, markdown. Now cell type, markdown. Click. Okay, now it has the funny font again, the blue one. Shift enter. Oh, it looks a little bit different, right? Smaller font, because it's like a subchapter. Okay, but now we really want to add numbers, do we? So I put 2 plus 2, okay? So you know what's 2 plus 2? Obviously you do. So I press Shift and Enter, and you see I have a little problem. my notebook is not connected. So something went wrong. But when you press Shift and Enter, you should get the correct answer. Let me restart. Restarting the kernel. Still got an error. 2 plus 2. Nope. That will not work today. Shut down. So does 2 plus 2 work for you? Yes, very good. Everybody got 2 plus 2? Not sure. So what we can try again is a console. Few options to fix things. Either we launch here. So I've changed now to a different computer because mine is not working properly. On the laptop, need to fix this later. So we're here back at adding numbers, right? So type, markdown. Typo, can fix. So we are 2 plus 2, right? And everybody got 2 plus 2 right. So far, so good? 2 plus 2, yeah? Very good. How about 2 times 2? So far, so good? Yes? Okay. How times 2 to the power of 3? Does it work? So when we want to have something in the exponent, we put 2 multiplication signs. Make it a little bit larger. Okay. Scroll down. So 2 to the power of 3 is 8, right? 2 times 2 is 4, times 2 is 8. Now we can add a markdown saying we want to compute 2 to the power of 3. Do you see what magic just happened? So in the code, I write 2 to the power of 3 with 2 multiplication signs. But in the markdown, I can expand a little bit in a more human readable format, text. Okay, so how do we get the 2 to the power of 3 in the markdown? We open the markdown by double click, and now we see, okay, we want to compute $2 hat $3. The dollar says, hey, start LaTeX markup language. So we start some LaTeX and we end some LaTeX when the dollar sign appears the second time. And they had 3 means, okay, put something in the opponent. The exponent, not opponent, exponent, okay? So far, so good. Still a lot of excitement. Okay, but now we want to write down a variable, okay? So we write a equal 2 to the power of 3. Good? So far, so good? Yes? A equal 2 to the power of 3. But later we know already we want to have a second a. So we need to give this a special name. Let's call it A1. But this looks very funny, right? This looks like 8 times 1. So we use LaTeX again. Click here, click there, add a dollar sign to say we start LaTeX. Now we use an underscore, okay? The line at the bottom, the underscore. And we end with a dollar sign at the end. And now the 1 is in the index. Can you see this? A1. So it's not 1 times, it's not A times 1 anymore, it's A1. Okay? It equals 2 to the power of 3. So far, so good? Again, I open the markup, and the magic happens here, where we have dollar underscore, what we want to put in the index, and we end at the dollar score. The same for the exponent. Okay, but now we want to be funny, right? So we say, hey, we don't want to have 2 to the power of 3. I can do this in my head. Let's use Python to use and make something more cumbersome. Let's write 2 to the power of 30. 2 to the power of 30, okay? Oh, this didn't work out well, did it? Now look at that. 2 to the power of 3 times 0. This is not 2 to the power of 30, right? Good. How do we change this? So the head notation and the index, index notation only take 1 character, unless you say, hey, let's use a curly bracket. So I put the 30 in a curly bracket, and then LaTeX knows, hey, I want to put the whole thing into my exponent. It's not only the first one, everything that comes after, until the curly bracket closes. So far, so good? So far, so good? Okay, but now the result down here is wrong, right? We still have 2 to the power of 3, and it's correct, but we can do this in our head. Now what do we get? 2 to the power of 30? Yep, that's more like it. So far, so good? So do not start using the curly bracket down here, right? Don't do this one. This is like wrong, because one part is your markdown language, right? Your LaTeX, where you want to have a human readable format. The other one here, where it's written in, this is Python, and the curly bracket don't make sense there. So, but this is a good chance for us to see what Python tells us when things go wrong. Right? This is one of the things. Okay, it tells you a type error. Unsupported operand type for star star or power int equals set. Well, it tells you, well, what you use there is actually a set, and we can't put a set into the exponent of an integer. So we remove this, and we just do the right notation. So far, so good? Very good. So now about how we say a1 equals 2 to the power of 30. What happened? Where's my value? Well, here's the thing. In input line 7, here 7, right? We asked Python to give us a result of operation. And the operation is, hey, put something into the exponent of something and tell me the number. In this line, input line 8, we asked Python, hey, do the same operation, but store the information into A1. Python does this. Python is not, I did what you told me to do. If you want to know what is stored in A1, just ask me what is in A1. Okay? And it is the same number. So far, so good. Shall we try to divide stuff? Everybody is still following? So how about 2 divide by 2? What could I do for divide? Like this? No, right? We normally use this sign for division. Well, 2 divided by 2 is 1. But 2 minus 1 is also 1, isn't it? Is there any difference? Are the numbers the same? No, right? So they look slightly different. One is 1.0, the other one is 1. They might be different in a way that, hey, let's use our first keyword, type. So our first result is a float, meaning it's a decimal number. Right? So we have digits after the decimal point. And the other one is an integer. That means, well, it's a whole number, 1, 2, 3, 4, 5, and so on. Generally, this is not a big issue in many cases, but sometimes we need to be more specific on which data type we expect, because there are requirements in certain functions, right? But we will see this. For loops, for example, so iterators are an example, but we are not that far in the course topic. So let's see, we have addition, we have multiplication, we have even the power, we have division. What else is there? Python as calculator, adding numbers. Well, we should have maybe produced more subchapters. Anyhow. What other mathematical operations do you know? Let's add so how about we just compare numbers? You probably did this in primary school, right? Did you ever compare, is 4 less than 5? Is 4 less than 5? Right, right? So when we ask Python this question, Python will tell you, yes, true. How about 4 more than 5? Is 4 more than 5? It's like primary school here, right? But now we do Python, and let's see what Python does with it. False. Okay. Okay. So now is 4 equal 5? But be careful here, because it's a programming language, and each symbol in a programming language has a meaning. When you scroll above, we use the equal sign to say, hey, this value, 2 to the power of 30, put into the variable a1. If we now use the same symbol, Python will try to apply the same operation. It will try to put the value 5 into the value of 4, which is a little bit weird, right? So what will happen? Oh no, cannot do this, can't assign a literal. That means, well, we cannot put the value of 5 into 4 because this will just turn out into madness. So what we need to do is to check if 4 equals 5. We use 2 equal signs, right? Equal, equal. And then we get false because 4 is not equal 5. We can check, is 4 equal 4? That is true. And we can check, is a1 equal 2 to the power of 30? So this is also true. So far, so good? You got all that? Still see typing, which is okay. Take your time. So important today is you have seen solitaire, very good. Okay, never mind, too easy. It's okay if it's too easy. So we already have seen some operations, right? We have some logic statements here, right? Saying that, hey, 4 equals 4, that is true. We have seen false statements, right? 4 is not more than 5. We have addition, subtraction, multiplication, and the exponent. I think I forgot one. Add, subtract, divide, multiply, exponent. That is fine. What we have not done is trigonometric functions, right? I can be louder, much louder. Is it better? No, it's better. Anyhow, there should also be the audio stream somewhere else. Okay, so trigonometric functions. Nobody asked? Sine, cosine, tangents, sine, hyperbolicus. Shall we try? Yes, okay. Good. So, however, that is not so easy, right? So we just put sine here. Well, sine is not defined. Well, sometimes Python, or the core language Python, has limitations, right? One of the limitations is, well, it's not designed to have trigonometric functions. So what we do is we extend its functionality. That goes a little bit ahead of the course already. But what is done here basically is say import functionality called NumPy. NumPy means numerical Python. Right? What is this course about? Numerics. As NP. So we will call this functionality NP. Shift Enter, and if it works, you don't get a complaint. But now we can use the edit functionality dot. We look for the sign in this edit functionality, and we give it a number. How about 0? Well, the sign of 0 is 0. Do you remember the value of pi? What's pi? 3.14 something something, right? So when we go 1/2 period in with the sign, we should be back at 0, right? Well, this is almost 0, right? Because we cut pi off at the third digits. However, at pi/2, we should be close to 1, right? Let's divide our pi approximation by 2. Yes, and we get a value close to 1. Very good. How about we want to know the value of pi, and then we ask NumPy, hey, what is pi? And then we get a value, okay? So NumPy.pi, pi, and we get the value of pi. I could either copy the value, plug this back into my sine function, and I get value close to 1. So far, so good. Or, who wants to work with so many digits? We just do NumPy.pi. Okay, so far, so good. Difficult, easy, unusual, right? But not difficult. So far, so good. A little bit of discussions in the back, which is all right. So one other function you will need often is the square root, right? So square root of 9 is what? 3, right? Okay, seems to work. Square root of 141 is what? 11.87 something. Very good. So we know this as well. Seems to work. If you want to really check a little bit, and of course use 121. Which other function do we need? The logarithm, right? What is the logarithm of, let's say, 10? Is that really 2.3? Shouldn't it be 1? So we have different logarithms implied. We have the natural logarithm. We have the logarithm for the basis of 10. We have the logarithm actually also for the basis of 2. 2. There we go. So from our 2 to the power of 30, right, the very big number, we plug the value in here as a 1, and we go back. We get back the result of the exponent, which is 30. So is there anything what you think your calculator can do better than Python? And you have a calculator on your phone, right? Or maybe from your school time you have a calculator. Is there anything you're missing? Add, subtract, log. You know your calculator? Log we have here, right? Log 10, log 2, log Euler. I think we are pretty much done. So everybody, no? Anything I miss? Here, this is how my calculator looks like. Very simple. I think you can turn it and then, oh, so nice. What's it? Cosine, tangents, degrees, sine hyperbolicus, random numbers. I think it's okay. No, yes, maybe. Okay, so in principle, we could have now an exercise. A very simple one. So I started giving you headings, right, with markdowns. They're incomplete. So what you could do is, well, to get muscle memory basically is to say, hey, I add some markdowns here. And introduce all the different headings. It's a little bit boring, isn't it? But well, you build up muscle memory in this way. Okay, let's see if that is done and if there are no comments or questions. Any comments or questions? If there are no comments or questions, we can basically look more into the naming of variables. Okay. We can start into something actually more important. Function definitions already. New notebook. Okay, so we have a new notebook now, untitled. I want to give it a name, right? Oh, when I double click the name of the notebook, I can say I give it a different name. I call it functions. And then in my home folder, I will see IPython notebook, I, P, Y, and B functions. Now, functions are very helpful because they help to structure code. To make a function, we will use our first, this is the second keyword, right? Def adding numbers. Careful, everything must be one string, one name. And I write here def adding numbers, and I give number 1, number 2, and then very important, at the end of this line, I add a colon. A colon are 2 dots. So far, so good. And you know that everything is right when you press enter, not shift enter, just enter. And you see the Jupyter Notebook helping you with some indentation. The indentation is a space that is used away from the initial position, shifted to the right. So far, so good. Now I can say my result equals, well, we already know how to add numbers, right? Number 1 plus number 2. So far, so good. So what's going on here now is saying that, so this function, which I give a name, adding numbers, takes two numbers, number 1 and number 2, from somewhere, right? So we, as the user, have to provide the numbers, but within that function, I am going to use the function number 1 plus number 2, add them up. The equal sign says store the result in result. Right, so you get number 1 plus number 2, and you get that one, store in the result. And now we say, hey, function, return me the result. So far, so good. Shift Enter. Now I can call. So what I do is I type add, and then I press the tabulator button. In Python or Jupyter Notebook is auto-completing. That means I don't need to type everything. I just add adding or add, and then I press one button, tab, TAB on the left, one, and it auto-completes the number, the name, because it knows the name. Okay. This is one sign that, hey, I did my function definition properly. Python knows this. Then I can use it. So I want to add two numbers, 9 and 7. And you see the structure, right? People will call it actually syntax later. That's very similar between what I call what is called the function call when we use the function, and the function definition. The function definition here, def, right? Def for definition. I press Shift Enter. What do I get? 16, is that correct? Okay, good. Good. So how about we do something differently? So I take my code, I copy, so far so good, but I'm a little bit like, I think maybe I don't need this one here. How about I just return 1 plus 2, basically. So number 1 plus number 2. Can you see the difference? So in the first example, I take number 2 and number 1, make a new one number, store the number in result, and return result. How many steps? Add, store, return. Do I need to store? Maybe I don't need to. What about I just add up and return immediately? So I have two functions. I give it a different name, version 2. So adding number v2 version 2, Shift Enter. How about copy paste again? Yes, very good. v2. Hey, this also works. So what do we learn by this comparison? Well, there are always different ways of achieving a goal, especially programming, right? But you need to have a clear definition. Hey, this is my problem, this is what I need to do, and this is what I want to have at the end. There might be difference, or this is what I need to do, but the result at the end must be correct. For example, maybe I work late at night and from plus to minus just one button difference, right? So you write a function adding numbers version 2 and suddenly 9 plus 7 is 2. Python will tell you, okay, if that is what you want, if you want to have a function called adding that is subtracting, I can do this, no problem. And you will get a result. But this is probably not what you want. So you must check if everything is correct. And besides the syntactic and syntax languages, syntax mistakes. Okay, a little bit of discussion again, which is okay. So we only had one break, right? Not two. Means we can finish in 15 minutes. Okay. Still a little bit of discussions. Easy, difficult? Easy so far, right? Maybe I go around once. Check. Everybody got the function? You're also good at this. Very good. Very good. Ha, this is working very well. Yes, yes. Does it